So again, we're going to start with how I hook up the wait to start light, and then we'll transition into the grid heat. So to find the circuit, we're going to still use our 6.5 liter diesel, and we're going to use the engine performance circuit. And you're probably wondering, why would you use the engine performance wiring diagram? Well, the answer is, if you study this stuff, and all of this over here on the left is the powertrain control module. The powertrain control module is what actually controls the glow plugs on the existing 6.5 liter diesel. So right here, it's this dark blue wire. It's pin number 7. So we're going to trace this dark blue wire, pin 7, all the way back to see where it goes, so that we can identify how the circuit actually works. I struggled with how to effectively communicate this information in a way that would make sense and also show enough detail and educate you guys enough to where you'll be able to actually tackle this on your own. And I thought that I finally came up with using these interactive wiring diagrams was the most effective form of communication I could give to try to demystify some of this stuff. Okay, so getting back on track, we traced it back, this dark blue wire, from the powertrain control module, and it goes into the instrument cluster, obviously the wait to start light. Okay, and as you can see right here, this dark blue wire goes into the instrument cluster, through the wait to start light, around to this node, down to pin number 4 on the instrument cluster, comes out, turns into a tan and white, and goes to a ground number G119 on the right hand top side of the cylinder head. Okay, so what this tells me is that the wait to start light needs to get power from the glow plugs, or from, in our case now, since we've done a Cummins swap, the grid heat. Okay, so we're going to trace this dark blue wire and see where it ties in and gets power. Okay, so it goes over here to line number 1 on the next figure. So we're on the 4th figure, line number 1, dark blue, right there. And lo and behold, it comes up and it loops around through a fuse. Now, most of the time, the underhead fuse block has a fuse that goes straight through, like this engine fuse right here. It means that it's tied directly into the battery, into the ignition switch, or something like that. But in our case, this glow plug fuse, or our wait to start light, just loops around, meaning it doesn't tie into the battery. It gets power from somewhere else, and as it turns out, it gets power from this orange wire right here. Okay, so our dark blue wire comes up, goes around, goes through the glow plug fuse, and goes to that orange wire. Okay, so now we're going to trace this orange wire down and see where it goes. So the orange wire comes down, and it gets its power directly from the left bank of glow plugs. They're all tied together, and this left bank of glow plugs gets its power from this orange wire. So where does that orange wire go? It goes up to a fusible link, which comes from the glow plug control module. Okay, so just to recap, glow plug control module says turn on the glow plugs. It sends power out of this orange wire, comes back up through this orange wire, through our glow plug fuse, around, turns into the dark blue, and goes back over to our light, turns our light on. Glow plug control module says I'm done, everything's hot enough, and it shuts the power off. Okay, so for our purposes, since we're converting over to a grid heat system, what you guys are going to need to do is you're going to need to identify this orange wire. The orange wire, that comes directly out of the glow plug fuse, this one right here, that one. And you're going to need to cut it and take it away from this left bank. And you're going to land that orange wire in one of two places. Either directly on the power supply to your grid heat, or the solenoid that controls your grid heat. That's where you're going to take this orange wire. And when you do that, this orange wire is then going to steal power from your grid heat. And when the grid heat is activated, meaning you have power going to the grid heat, it's going to flow electricity through this fuse around into this dark blue wire all the way back to your instrument cluster and turn on your wait to start light. So that brings up the question, okay, well, how do you control your grid heat? And probably some of you have seen from some of my other videos, you can control your grid heat in two ways. The first way is the simplest, which is a momentary rocker. Meaning, as long as you are holding down on the rocker, then it's triggering the grid heat solenoids and the grid heat is heating up. When you lift up on the rocker, it stops. That's the simplest way to do it. You are the one that is controlling how long the grid heat is heating up. A more advanced way to do it, which you could still use the momentary rocker to trigger, is by controlling the grid heat solenoids with a timed relay. Meaning the relay turns on power to the grid heat as soon as you either A, push the momentary rocker, or B, turn the key on. If you want a fully automatic timed relay where you don't have to think about it, you don't have to push a button, then the best thing to do is to install a timed relay and have the timed relay triggered by a key on circuit.
So it seems appropriate to reuse your existing circuit off of your GM vehicle that supplied power to your glow plugs and things like that for your new grid heat relay. And as it turns out, on our test subject, the 96 K2500, it just so happens that the engine 1 fuse, which is hot in the run and start position of the key, 20 amp, feeds the fuel heater, and it also comes over, if we trace this wire, it comes over to your glow plug control module. So it would make sense that now that this glow plug control module doesn't exist anymore and you're going to replace this glow plug control module with a timed relay or a toggle switch, then you would feed power to that relay from this circuit to try to stay consistent with your wiring. Just like for the transmission, we utilize the existing GM transmission circuit to supply power to our US shift controller. We're going to use the engine 1 fuse 20 amp to supply power to our trigger for our grid heat. Okay, so that just seems to make sense. You can see it goes into this node right here, and so it branches off and controls a lot of different things. So in order to find this wire on your on your GM vehicle, you either have to find the pin A on the glow plug control module unit itself, terminal A right there, and use that, or you could identify your fuel heat and pick it up right there, or your EGR valve, or any number of these three other circuits. So let's see where this one goes, just to give you another option. And the reason why I'm pointing this out is that sometimes, depending on where you're going to mount your control relay, utilizing existing wiring harness pigtails that already route the wire over there with the OEM connectors on them gets you a little bit closer, so you don't have to splice and extend as many wires. So